Okay. Good morning, students. Good morning, everyone.
Good morning, sir.
Okay. This morning. Well, before that one, thank you for coming for this very special session. This is a special session because you will be knowing more about mathematics. Okay, but before that one, I'll be flashing to you showing you some pictures. We have this. So what can you say about this one? Anyone? Sorry. Thank you. So what can you say about this one? Any observation? Yeah, there are some what? Okay, shapes. So what are the shapes? We have? Okay, how about this one?
Irregular shapes.
Irregular shapes. That's good too. Okay.
Spatial figures.
Figures. How about this one? There are also shapes.
Yeah.
Okay, this picture. How about this one? Another
3D shapes.
Yeah, another. Okay, and what do you think is the common observation that you can create out of these pictures? Okay, there are made of objects. Okay, and these objects are in shapes, in different forms. So meaning if we're going to combine all these shapes in different forms, you can create a good figure. Okay? Now, one would thought after observing these pictures, the geometrical figures. Have you heard that one?
Yes.
Okay. Geometrical figures is actually our topic for today. Now, it is actually present all over around us, even in nature. So, are you familiar with this?
Yes.
Okay. What is this?
Chocolate.
Chocolate hills. And remember, chocolate hills is one of the most visited places during summer here in the Philippines. And it is actually a lot of people were actually mesmerized of its beauty because of this, again, this composed of geometrical figures. Now, so much of this, again, the pictures that you have seen a while ago, you can have this common denominator, which is a geometrical figure. And when we talk about geometrical figures, these are the terms that we will be thinking of. We have shapes, pictures, beauty, mathematics, physics, and even art. Are you? Do you agree?
Yes.
Now, this morning we'll be talking about geometrical figures. And among these geometrical figures, we'll be talking about parabola. So this morning, the things that we'll be accomplishing are these. We'll be talking about conics. We're going to define what is the conic section, or simply conics. And then among these conics, there are several types of conics. So we'll be focusing more on the parabola and then its types. And we'll be deriving a formula in standard form and its general form. And then, of course, we're going to identify and discuss its properties. And finally, we're going to graph the parabola using its properties. Okay? Now, conics. Conics is defined to be an intersection of a plane and a double neck cone. Okay? So, we have this is a double neck cone, and this is a shape. Now, if we will let the two intersect, there are several intersections that are being formed, and we call them as conics. Example, let's say, this is our double neck cone, and this is our plane. As I have said, if we will let the two intersect, there will be several forms to be created. Again, it is the conic sections or simply the conics. Now, when we let the two intersect, there are two groups of figures that will be formed. We call them as the non-degenerate conics and the degenerate conics. Now, when we say about non-degenerate conics, we have the parabola, we have the circle, we have the ellipse, and the hyperbola. And when we say about degenerate conics, we have the point, line, and two intersecting lines. Now, the next question would be, what will be now the behavior when we let this double nape conic, double nape cone and the plane, in order for them to create a parabola, circle, ellipse, and hyperbola. Accordingly, if this particular plane intersects this double nape cone, and this one does not contain the vertex of the cone, then the figure will be created is called the non-degenerate cone. Example. Try to imagine this, so let's say this is our cone and this is the plane. So if we will let the plane intersect our cone in this manner, it will give you a circle. And try to observe the plane did not contain the center. Okay. Now, let's say another behavior. Let's say this is our plane and we will let it intersect in this manner. So what do you think is the graph? Will give you the ellipse. And again, this particular plane does not contain the vertex. So we'll be talking about this one more as we proceed to the other types of the non-degenerate cone. Our main concern today is this one, the parabola. Okay, so again, for a non-degenerate conics, the plane, when we let it intersect our double nape cone, it did not contain the center or the vertex of our cone. Is the vertex of the cone. Now, if this particular plane intersect our double nape cone, and then it contains the center, the particular figure will be formed is called the degenerate cone. So meaning, point, example, this is our plane, if we will have it like this. So the common intersection is the vertex. So the conic now is a point. How about line? If we will have this like this, it will give you this particular intersection. Okay, and then of course the two intersections. We will have a separate session for the degenerate points. For now, as I have said, because of these objectives of ours for today, we'll be talking about more on the parabolas. Okay? Are you all excited to know about parabola? Okay, now, parabola is defined to be, who would like to read the definition of the parabola? Michelle?
So, a parabola is a curve consisting of a set of points P whose distance from a fixed point or the focus is equal to the perpendicular distance from P to a line or the directrix that does not contain the focus.
Okay, now, these are now the things that we need to remember when we talk about parabola. We'll be talking about the fixed point, which is known to be our focus, and of course the fixed line, which is known to be our directrix. Okay, these two are actually the first two common properties of our parabola. Okay, but before that one, shall we go back a bit about circle? I know you are very much familiar with the circle. So what are the two properties in graphing a circle? Okay, we need the center, and of course it's the radius. Okay, so when you say about center, it should be in the fixed position, right? Because if we won't be defining our center, we could not be able to determine which will be creating our circle. And so with the radius, because without the radius, we do not know, or we won't know the size of the circle. So therefore, these are the two properties that are needed in order for us to create our circle. Okay, same thing with graphing a parabola. There are properties that we need to consider. Okay, now, let's say our parabola is accordingly. So we need to define first our fixed point. Let's say our fixed point is this. So what is this?
0, 0, 0.
Okay, 0. So the coordinates are 0, 0, or the center or the origin of our plane. Okay, let's say this is our fixed point and we named it to be our focus. So let's say this is our M. Okay, next is we have the directrix. So let's say our line is this one. Okay, so this is now our directrix. So this will be now our references to create our parabola. So going back to its definition, it is actually a set of points. So a group of points, which are actually equidistant from these two. Okay. Of all the points here, which is obviously equidistant from the fixed point and the line? Okay, this one. Because it is equidistant from this 1 unit and 1 unit, so there one. Okay. So we'll pick another point. So which is equidistant from this and this, so let's say this one. Okay, its distance is equal to this distance. So I have point 1 and then point. Another is, shall we pick this? So this particular point, so let's say P1, P2, and then P3. Okay, its distance is equal. Okay. Now, before this one, what is the formula to determine the equation or to determine the distance of 2 points or the length of a segment? What is the formula? Yeah, the distance formula. What is the distance formula? Okay, so the distance for the square root of, given the two coordinates, we have x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And where did you get this one? Where did you get this one, this particular formula from? A Pythagorean theorem or right? Okay, so before this one, because we'll be deriving our formula later, this one. So we need to, because we'll be using the distance formula for point 1 to point. Okay, now going back to this, now if we're going to pick another point and so on and so forth and collect them and connect them, it will give you this. And the same manner with the other side, so it will give you this. So this is now our parabola. Okay? So again, these are actually composed of infinitely many points. Again, that follow this particular behavior, that they are equidistant from a fixed point, which is known our focus, and then a fixed line, which is known to be our directrix. Okay? Now, accordingly, when before we'll be having the derivation of the formula, there are these 3 types of classifications of parabola that you need to consider first. Because the position of your parabola, meaning the formula of the parabola or the equation of the parabola, depends on what particular position your parabola is. Okay, so you need to consider that one. So before we'll have to derive the formula, shall we visit first the 3 classifications or types of parabola? Accordingly, by the way, when we have the conics, the intersection of the double nape cone and the plane to create a parabola, this is how it is being done. Okay? So this, we will just pick one part of the double nape cone and we will let the plane intersect in this manner. So this is now our parabola. Okay. Now, again, there are 3 types of parabola. So depending on how it is being drawn. Why? Because the equation or the general equation of the parabola depends on what particular position. Okay. Now, for a regular parabola, the position is vertical. So it is a parabola opening upward and the parabola opening downward. For the horizontal type of parabola, so this is being drawn sideways. So this example. What do you think is the third? Okay, the oblique. The third is the slant or oblique parabola. Later, you will notice that when the parabola is in vertical position, which is known to be regular, the variable being squared is x. But then for a sideways or horizontal parabola, you will notice that the variable being squared is y. How about this one? Do you have any idea? So this is actually one of the things that you need to learn when we talk about parabola. Okay, but this morning we'll have first the regular parabola. Okay, to give you an advanced information about slant and oblique parabola, if the second degree equation contains a term xy, it will give you, what is that? Okay. Now, when we say about xy, it is basically a hyperbola. Now, meaning for a slant hyperbola, there will be a different equation for that. Okay, because we're going to translate and rotate the axis. Okay, so you will be knowing this more when we reach this particular topic. For now, again, we'll be having the vertical or regular parabola. Okay, now, same thing with the circle. The two important properties of a circle are the center and the radius. And these are actually needed in order for us to graph completely our circle. So for a parabola, there are also properties that we need to identify in order for us to graph completely our parabola. So these are the directrix. And again, what is a directrix? Okay, it is a fixed line. This is not just a line, it should be a fixed line. Okay, how about the focus? A fixed point. Okay, so let's say this is now our hyperbola. So this is now our fixed line, the directrix, the focus. Okay, now, how about the axis of symmetry? Okay, the axis of symmetry is actually the line which is perpendicular to your directrix. And because of that axis of symmetry, the parabola is also defined like this. The name parabola is derived from a new Latin term that means something similar to compare or balance. So you notice that there's a balance. So if this is the axis of symmetry, there's a balance to these particular points, given this particular point, so this particular point. So there's a balance. Okay, so because of this axis of symmetry. Okay, another important property of a parabola is the latus. And you will notice later that the focal distance. Okay, so speaking of focal distance, the focal distance is actually the distance of the focus from your vertex. So meaning if this is the focus, this is the vertex, this particular length is your A. That's the focal distance. Okay. Now, if this is A, what do you think is the value here? A is also A. Because now, if our focal distance is this, now the important property of a latus rectum is it somehow guides you to graph our parabola. So it's basic. Initially, it will help you to determine the opening of your hyperbola. So the latus rectum here, so this is actually the latus. And the length of this is 4. Okay, so to graph a parabola, we need to identify the directrix, the focus, axis of symmetry, the latus rectum, the focal distance, and the vertex, in order for us to have the complete graph of the parabola. Okay? Any questions so far? Clarifications? Okay. Okay, again, what is the purpose of the latus rectum? Yeah, to guide, yeah, the opening of the parabola initially, because we're going to have it like this. So if the latus rectum this is the length of the latus rectum, so initially this will be now the opening of your rectangular. Okay, without the latus rectum, all you have to do is you're going to approximate its opening. So again, to have a complete graph of the parabola, we need to have it. Okay, now, let's say, the question now is how to determine the directrix, how to determine the focus, axis of symmetry until vertex of the given parabola. Okay, so what we will be needing now is its equation. The equation of the parabola will help us to determine the directrix until the vertex of the parabola. Okay, so now our next topic is to derive the parabola. Okay, let's say, okay, can I clean this one?
Yes.
So, our next topic now is to derive. Given this parabola, okay, shall we pick the easiest? Let's say this is the vertex, 0, 0. Okay. Shall we say this is now our hyperbola? Parabola. Okay. Now, shall we say this is our focus? Okay. Now, shall we define our distance or the focal length, our P with the focal distance? Again, what is the focal distance? The distance of a focus from the... Do you think the focal distance is important? Yes, because it will help you to determine also the directrix. Because we have the same. Okay, let's say this is our P. So what can you say about the coordinates of this point? So this is 0, P. Okay. And then of course, if this is our P, if we have this negative P, or rather the absolute value of negative P is actually the length. So this is now our directrix. Okay, so this is now our... Okay, now remember this composed of infinite. Our objective, please put in mind that we're going to derive now our formula for the parabola. What is our next goal for this? Because we wanted to know the properties. Because the properties are actually very important to have a complete graph of our parabola. Okay, now, shall we have a point here? So let's say this particular point is x, and this is our y. So this point now is x, y. Okay? Now, accordingly, now we have this particular definition. From this particular point to here, so let's say this is our Q, this point Q, and this is our point P, and this is our, okay, this is our directrix. So we define it to be our D. Okay? Now, if we will go back to the definition of the parabola, what is the definition of the parabola? Okay, so meaning we have this particular point is equidistant from this point and this line in the directrix. So therefore, we can create an equation which is what? Your QP, the length, or meaning the distance of the QP, the length of segment QP is equal to what? So we say this particular point is our D. So it is equal to what? Okay, so the D Okay? Okay, so this particular point from P to G, what do you think is the distance? The distance or the length? Okay, so it is actually, from here to here, this is actually negative P, right? And then, plus this one, we have what? No, this particular point. What is this? This is your y. So therefore, we have this dp is equal to what? The distance. We have, okay, y plus the distance, p. Okay? What do you mean by this? Do we have a negative distance or length? No negative distance or length. So therefore, this particular length is p plus this one. This is your y, right? This particular point. So therefore, all in all, this particular green segment is x plus y units. Okay? Now, next is the QP. Okay, the QP. Now, you will notice if we're going to enlarge this particular figure, it will give you this. Okay? So, what is the coordinates of this point? 0, 3, right? This one. And this one is? So observe that we have a right triangle. Okay? Now, to determine this one, we will use the Pythagorean theorem. Okay? Now, again, our objective is to derive the formula in order for us to determine the properties. Okay? Now, what is the distance of these two? We will use the Pythagorean theorem or simply the distance for this. Okay, so QP is equal to what? Square root of, what is your x? Shall we say this is your P1, this is your P2. So therefore, it will give you what? X squared, or let's say x minus 0 squared plus what? Okay, y minus p squared. Okay, if we will simplify this, it will give you what? Square root of x squared plus y minus p equals y plus. Okay, now simplify this. So shall we say squaring both sides, it will give you what? So, di ba, cancel. Next, we have what? X squared plus y minus p squared equals what? Y plus p squared. Expand, it will give you x squared plus y squared minus 2py plus p squared equals
y squared plus 2py plus p squared.
So you'll notice that we can cancel out y squared, p squared, and p squared. So this will lead you to this particular equation, which is x squared equals 4p. So this is now the general equation of your parabola having vertex 0, 0. Okay? So this is now the parabola, the standard form of our parabola having vertex which is 0, 0. Again, what is P? Okay, P is our focal distance, meaning the distance of the focus from the. Okay? Now, given this particular equation of your parabola, you can determine the properties. Example. Okay, so any questions so far? Clarification about the derivation. So, you've noticed that we just work out the length is equal to this particular length. And apply simple algebra, you've reached the x squared equals 4ey having a parabola with vertex 0, 0. Clarifications before proceed to its application. Clarification. Now let's say our parabola is x squared is equal to, let's say, 8y. Okay, so we have x squared is equal to 8y. Now, the question here is you're going to graph the parabola. But to graph a parabola, what are the properties that we need to consider? We need its vertex. We need its focus, the directrix, the axis of symmetry, and of course the focal distance, and the latus. So these are the important properties that you need to know first in order for you to have the complete graph of the parabola. Okay, given this equation of the parabola, you need to graph it, so we need to identify this one. Okay, based on this particular equation, what is the vertex of the parabola? Okay, so the vertex of the parabola is 0,